So today I'm going to go over the Unit 2 Lesson 1 practice problems that were assigned. The first one, number 1, is that we're looking at these three shapes to decide which one does not look like or match, meaning it's different, the others. So, and it even gives us the hint to compare the height, the width and height. So what we want to do is set up a ratio using those two things. So I'm just going to set up a nice chart because I know I'm comparing the width to the height. And hopefully you're listening to this because it is difficult for some reason today to write with this stylus. So I've got A, B, and C. So I'm going to look at the ratio. So the width, first of all, of A, I would count across, and I would notice that this is 5 units across. And the height, if I count the height of it here, is 4. I do the same thing for B. I look at the width across. I notice that this is 10. And then the height of B is 8. Again, for C, I look at the width of C. It is also 10. And its height is 6. So basically, I want to look at these three, each of these three shapes, A, B, and C, now that I've put them in a nice chart, and see which one of these two, or which two of these, is proportional. It should be fairly obvious, but I'm just going to set up a nice way that you can see it. If I set it up like this, 5 to 4, and I want to say to myself, is that equal to 10 over 8? Well, is there a number that I can multiply both 5 and 4 by to get to the new ones? Of course it is times 2 and times 2. So these are the same. Now, since this is already 10, and I know that 10 has to be 8, I know that this one is not the same. So C is different. Got that? The next problem that we had to do, number 2, we're looking at trail mix. And this trail mix is comparing peanuts to raisins. I only have 2. I've got one version and another version. So I'm going to use all those words because I like to use words first when I set up these proportions. And I know, again, I'm comparing peanuts over raisins. And I'm just going to label these as 1 because that's how it refers to it in the problem, and another. So I've got all my words here. So now I really just need to put in my numbers and see if this is a proportional relationship. So in the one version, there are 3 cups of peanuts, 1, and 2 cups of raisins, 2. And in another version of the trail mix, there are 4.5 cups of peanuts and 3 cups of raisins. Now, there are numerous ways to do this, but let's look at the first way to see if they share the constant of proportionality. And the way that we would do that is to simply divide. So I would look at, if I'm going in this direction, I want to divide, always. It's the same exact thing as that scale factor, the way that we would, going from left to right, multiply, going from right to left, divide. So if I did 4.5 divided by 3, I know I personally really like to think about this as, wow, let me undo whatever crazy thing I just did here. Okay, I'm going to rewrite that. Sorry about that, folks. So here we are. I obviously pressed a wrong button that I won't do again. So again, 4.5 divided by 3. I like to think about this as money, if I say this is $4.50, even though we know it's not in this particular case, we know it is cups. But if I had $4.50 and I wanted to divide it by 3 people, I should know that I should easily be able to figure out that would be, oh, the green doesn't really work, that would be 1.5, or $1.50 if I was still thinking about it as money. So 1.5. So in other words, 4.5 divided by 3, what I'm saying is 4.5 divided by 3 equals 1.5. So now we have to see if they share the constant of proportionality for the next two. So 3 divided by 2. 3 divided by 2. Now look at that. I know some of you are saying, well, 2 doesn't go into 3. Well, in this case, I just look at it as a fraction and reduce it. I know that 3/2 is equal to 1 and 1/2, which of course we know, decimal form, fraction form, these are the same. So it asks us, are the ratios equivalent? And we're going to say the ratios are equivalent. And I've already explained my reasoning by showing all of my work. And don't forget, that means that these two trail mixes will taste the same, provided that the other ingredients are also in proportion. So the last problem that we have to do is to prove that these, to write 3 ratios that are equivalent to 7:3. And the way that I would do that is to use the same constant of proportionality and multiply both top and bottom by the same exact number, any number I choose. So for instance, 7 times 2 is 14, 3 times 2 is 6, that's therefore equivalent. I could take 7 times 3, multiply top and bottom by, say, 10. That would be 70 over 30. And that would be another equivalent ratio. I could choose, let's say, to multiply both top and bottom by 5. That would give me 35 over 15. Again, equivalent. We could do both 7 and 3 times 1/2. So that I know looks a little bit funny to some of you. That's 1/2. And that would give us 3.5 over 1.5. Again, equivalent. To explain that, if I use the same constant, I promise that says constant, of proportionality, to multiply by both original numbers in the ratio, it will therefore be equivalent. And there's your explanation.